All right, our next lesson here includes the dreaded P word, proving triangles similar. And so one of the ways in which we endeavor to show that polygons are similar is to show that all of their corresponding angles are congruent, all of their corresponding sides are proportional. And what we're going to find here is that when we're dealing with triangles, we can actually take a handful of shortcuts. And so I want to describe those shortcuts just like we had congruence shortcuts in our Unit 4 a few months ago. What we're going to do is have a couple shortcuts here, a handful, to prove that triangles are similar. Those shortcuts are as follows. We have angle-angle similarity. We don't have to say angle-angle-angle because if we have two pairs of corresponding angles congruent, then we know the third pair of corresponding angles is congruent. We have the side-angle-side similarity and the side-side-side similarity. And so what we're going to do is try to explore how we can use and apply those. We'll do much of that exploration in class, but this is simply the information, just so you can have this information down, and then we can access it in class as we practice it together. So think back to when we were proving triangles, any polygons congruent in our first lesson of our fourth unit together. We found that we had to show that all of the corresponding angles were congruent and all of the corresponding sides were congruent. But when we were dealing with triangles in particular, we had a handful of shortcuts. We had hypotenuse leg, side, 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 angle, side, angle, angle, side. And so there's a whole list that we would explore there to kind of find key pieces of information and apply those key pieces of information. Maybe we do a little bit of exploration, trying to understand what does it mean if something is bisected? What does it mean if we have these lines parallel to each other? How do we know what parts, segments are congruent, angles congruent, etc., so that we could use that in our explorations and in our proofs. All right? And so I know that this might seem a little intimidating, but I promise that this will be a lot more low maintenance than what we dealt with in the fall. So instead of showing that all of the corresponding angles are congruent and all of the corresponding sides are proportional, we can use these three shortcuts. So we've got angle-angle similarity, side-angle-side similarity, and side-side-side similarity. Now, like I said, we're not going to do examples here. We're simply going to explain each of these situations. So angle-angle similarity just basically says if two pairs of corresponding angles are congruent, then the triangles will be similar. They have to be similar. Meaning, if we have two pairs of congruent angles, then we know that the sides will also be proportional. All right? And so that is our first clue for shortcutting triangle similarity. Next, we have side-angle-side similarity. If two pairs of corresponding sides are proportional and the included angles between those proportional sides are congruent, then those triangles will be similar. All right? Side-angle-side. So remember, we've got two sides and then the included angle. Two sides, two pairs of sides proportional and the included angle between them congruent. Those triangles are similar. The final one is side-side-side similarity. And this is the example actually that I did in the last set of notes that you may not have noticed, that I did not talk about triangle ABC and FED having congruent corresponding angles. I was kind of dodging that because we know if we show that the sides are proportional here in this conversation, then we know that those triangles are similar. All right, so there was a little spoiler alert there in that last lesson. But here, if three pairs of corresponding sides are proportional, then we know that the triangles will be similar. And so our goal in the practice that we will do in class is simply going to be, let us show that the sides are proportional. And if they are, then the triangles are congruent.